Hello friends, welcome to the last lecture on this third chapter, variables and keywords in C language. We were discussing about the resolution of global symbols by linkers. That's what we were discussing. And also we discussed the three rules, and also we discussed about strong and weak variables. That also we discussed. And also I think we finished discussing rule 1 with an example. And rule 2 and rule 3 also we would be discussing now with an example. So rule 2, if there is one strong symbol and many weak symbol after linking, then the strong symbol would be chosen. And also I would just like to recollect that strong symbol means either function names or initialized global variables, and weak symbols means uninitialized global variables. Okay. So let us look at the program towards the left. This is the program. So in f1.c, I begin by saying hash include stdio.h, and then I say void f void int x equal to 1, initialized global variable, hence x is strong symbol, after which int main, and within the main function I am calling f function, and then I am saying printf statement, and there is return statement to return back from the main function. So in f1.c, the global variable x is a strong symbol. So that is the only strong symbol that is present. After which, if we move on to f2.c, there is int x and semicolon should be there. Anyway, it's not initialized with a particular value. Therefore, x in the second in f2.c is considered to be a weak symbol. And then function f is there. So f is a function name which is a strong symbol. Okay. So I will repeat the symbols again. In f1.c, x is a strong symbol. Not only that, main is a strong symbol. Two strong symbols, no weak symbols. In f2.c, x is uninitialized. X is a weak symbol and f is a strong symbol. After which I would try to link these two programs, and you know how linking works. The lines of both the programs would be copied into a single program. Like this it would get copied. Hash include stdio.h, and then prototype, and then int x equal to 1, int x. There is a strong symbol called x, there is a weak symbol called x. So in such cases, which one does the compiler choose? It chooses the strong symbol, that is x equal to 1 only is the value. Now if I try to print, and then I will call the f function. So the control would go there. It would change x's value to 2, and then the control would return to the main function, and the printf statement I am trying to print x. So that x value that is printed would be 2. I hope. The output is x equal to 2. I will just return 2. I hope this is completely clear to you. So the second rule, it says if there is a strong symbol and a weak symbol or multiple weak symbols, strong symbol would be chosen. That is what is happening here. X equal to 1 would be chosen rather than int x. That will be, neglected. I hope the resolution of global symbols defined at multiple places is clear to you. Third rule also, it's very simple. Given multiple weak symbols, so many of them are uninitialized, you can choose any one of them and it would work fine. I wouldn't write an example program for rule 3 because it's pretty straightforward, and we have already had the experience of writing for rule 1 and rule 2. So I think you would be able to write it by your own. So what I would be discussing is, all this time I was taking small programs. Now I have taken two big programs, considerably big programs, and I'm trying to link them and get the output. So after watching this, I think you would get even more confidence as to how linking is done. What I am doing here is nothing but swapping two variables a and b using pointers. So in my first program, main.c, I begin by saying hash include stdio.h. After that, I have the prototype of the swap function, and then I say int a equal to 1, b equal to 2. Of course, a and b would be strong variables because initialization is done. After which, int main, in that I would be calling the swap function. After swapping, I would print the values of a and b. And in swap, I would reach extern int a comma b. So a and b, they are defined somewhere else. That is the meaning by extern. And then int star p is equal to ampersand a. That is how most of them read it. But you should read it as p is a pointer to an integer and it is collecting the address of a. So I will speak more as to how to read declarations in my future pointer classes. For now, for a person who has no, understanding of pointers, I would request him to watch either my videos on pointers in programming part, in C programming, or in general refer any book, so that once you have the basics, only then you can get into the depth in C aptitude. Anyway, the basics I have discussed in my programming videos. If you are finding pointers difficult, I would request you to refer that. I would just explain it once so that where I was about to say that int star p sentence, I would read it as p is a pointer to an integer and it has the address of a. In other words, p is pointing to the variable a. Diagrammatically also I have shown in the left side of the screen, if you look at it, diagrammatically I have shown p is pointing to the variable a, and then q is a pointer to an integer and it has the address of b. In other words, q is pointing to the variable b. That is what it means. And then void swap function, in that I have a variable called temp, which is an integer. And then when I use star before, when I say int star p, it means p is a pointer to an integer. However, when I use star, in the RHS, or when I use star non-declarative sentences, in sentences which are not declarations, that means star is penetration operator. If I use star in declaration part, then it means pointer creation. I have discussed these things in depth in my programming videos that I would be uploading soon. If you have any confusion regarding this, you can watch that. Anyway, when I say star p here, it means penetration. In other words, p will penetrate inside a and get the value. So a's value 1 would be given to temp. Then when I say star p is equal to star q, it means penetrate q and whatever is there, give it to penetration of p. In other words, whatever is there in b, give it to a. So a's value will become 2 now. After which I will say star q is equal to temp. So as I've told you, star in this case means penetration operator or dereferencing operator. When you penetrate inside b, then and then whatever is there in temp, put it there.